So far, we have learned how to factor. What's our first method of factoring that we've learned so far? When I give you a polynomial, what was our first method of factoring? Yes, sir? Finding the GCF is correct. Guys, that's finding the GCF step is the most important way of factoring. Even though it's the easiest, okay? Because if you don't factor by, so let me show you. If you don't factor out your GCF when you're factoring polynomials, it's going to be really, really hard. Okay, so if you factor out your GCF first, it's going to make your life a lot easier. Does that make sense? So this is the easiest way of factoring, by the way. Okay. Today we're going to learn our second method of factoring. Not only so after you look at GCF, you look at. So let me show you an example of GCF. So always factor GCF first. I cannot emphasize this enough. Okay, a lot of times people get stuck on the homework or on the test. It's because they forgot that they could have factored out GCF first. Okay. So write this down. And so the second method of factoring is called the difference of squares. I call it DS in short. Okay, it's difference of squares. Okay, so write that down. Difference of squares. So we're going to show you how we could factor some of these polynomials using this method, difference of squares. What does difference mean, by the way? Yes, sir. Subtraction. What does square mean? Something's being squared. Okay, so let's see if you remember this from last time. Hold on. So do you remember this example from last time? When we multiplied two binomials that looked exactly like, but one of them was addition, the other one was subtraction. Do you guys remember what happened? Yes, Ryan. Yeah, the linear term, what happened to the linear terms? They canceled out. Do you guys remember that? Let's refresh our memory. So what do we get? How do we multiply this? Well, let's make it into addition first. Then a times a gives you what class? A squared plus, right? Since everything's addition, all the operation in between these terms are addition. A times negative b is negative ab. What's a times b? Plus ab plus what? What's b times negative b? Negative b squared. Do you guys remember this? And what happened to this linear term? They canceled out, right? So do you guys remember getting something like this? A squared plus negative b squared, which is really a squared minus b squared. Do you remember this from last time? Okay. Now, do you think this will happen every time when you multiply two binomials that look exactly like, but one of them is addition, the other is subtraction? Do you think that linear term will always cancel out? Yes or no? Yes. Okay, so knowing this pattern, we are now able to factor something that looks like something squared minus something else squared. In other words, what's this called? Something squared minus something else squared. This is called the difference of squares. Right? Does that make sense? So if I have difference of square, how does this what does it factor to? If I have a squared minus b squared, it'll always be. Anybody? Yes, sir? Get canceled out. So again, if I have a squared minus b squared, if I have difference of square, how does it factor to then? Yeah. Eric? No. So we're trying to go back to this, right? Yeah, Sarah? Parentheses a minus b squared. Is that what we had before? Is that how we got a squared minus b squared? How do we get a squared minus b squared? We multiply two binomials that look exactly like, except one of them is sum, the other is difference. So a squared minus b squared would equal to, always when you factor, it will always be Okay, how do we get a squared minus b squared, guys? What do we multiply to get a squared minus b squared? A plus b times a minus b. What does it mean to factor? You want to write something as a? No. Say it again? As a product. Vivian is correct. So look, is this a product, a squared minus b squared? No, that's a difference of squares, right? How do we write that as a product? Well, you think back and say, how do we get this? By multiplying what times what? A plus b times a minus b. Guys, that's the pattern that you need to see. So this is a fact. This is the thing that this is the main focus. If I have a squared minus b squared, this difference of square, factor as what? A plus b times a minus b every time. Does this make sense? Hello? Yes? Write this down. Okay. Yeah, some of you said something interesting. If I multiply a plus b times a minus b, wasn't that a squared minus b squared? Right? That's how I know that this a difference of square factors as a plus b times a minus b. Does that make sense, guys? Do you see what I'm trying to say? How do we know that a squared minus b squared factors to this? Well, because we knew that whenever you multiply two binomials that looks exactly like, but one of them is addition, the other is subtraction, it always equals to a squared minus b squared. So if you want to write a squared minus b squared, the difference of square as a product, meaning if you want to factor it, it must look like a plus b times a minus b. Does that make sense? Okay. So then let's try this example. Oops. So here, I have x squared minus 25. Okay, so write this down. So, first of all, remember I told you before you factor, you should what should your step one always be? Whenever you factor, you should always do this first. What was it? Yes, sir. Eddie? GCF. Thank you. Eddie, do I have any GCF for each of these terms? X squared and negative 25?
Yeah.
I have a GCF of what?
5.
5? Is 5 my GCF?
Oh, negative 5.
Is negative 5 a GCF? Negative 5 does not go into x squared though.
Oh.
Yeah. Do I have any GCF in this case? No, I don't. Okay, so I don't have a GCF, so always look for GCF, but this time I don't have any. Does that make sense? So what's another way of factoring? We only know two ways. One is using GCF, the other is using this. Yeah. Now I can use the difference of square. Is this a difference of square? Well, I see the difference. That's fine. But I only see square for one of them. I don't see square for the 25. Yeah.
25 is 5.
Oh, right. 25 is 5 square, isn't it? Does that make sense? So I'm looking for this pattern, am I not? I'm looking for this something square minus something square. And is there a way to rewrite this so that it becomes something square minus something square? Yeah, what's your A? X. What's your B this time? B is 5. Do you see that? Does that make sense? Do they always have to give you A and B? No, they could give you X and 5 in this case. Does that make sense? So in place of A and B, they could always give you some other kind of monomial. Does that make sense? Or they could actually give you a polynomial if they want to. Anyway, so if I know that this is x squared minus 5 squared, who can tell me? Let's remember what difference of square told us. Remember that a squared minus b squared, what was that? That was what? How does this factor to? Yes?
A plus B
A minus b, right? So since in this case, since my a is x, my b is 5, who could tell me how this factors to? What does it factor to? How do I factor? Chris? X plus 5 times x minus 5 is correct. Everybody see this? Now, is there a way to check this? What if I know whether or not I really have the right answer? Is there a way to check? 2 people see it? 3? William?
Solve it.
Solve it. We don't have an equation. We don't solve this. We simplify. In other words, Claire, we simplify. How do you mean simplify? How would you do that? Yeah, you work it out. You simply multiply, right? And when you multiply, what did you expect to get? What would you expect to get?
X plus 5.
I should get x. Yeah, x plus. So so this is how you check. You just simply multiply them, right? When you multiply this out, you expect to get Yeah, if I got this right, I should get x squared minus 25. Do I get x squared minus 25? Go ahead, everybody multiply it out. Paul, did you have a question?
Last year was somebody told me a trick about this.
Oh yeah? Okay.
But when you have this like, x plus whatever, and it's the same thing, like, so it's x minus base b or whatever. You just like put x squared and then multiply the second monomial. That's your answer. Okay.
Right. So if you know the pattern, that's what you're basically doing, right? Exactly right. What Paul's saying is if I have x plus 5 times x minus 5, it's really first term squared minus second term squared. Yeah, that's the pattern that I'm showing you. Exactly. But when you want to check it, you just kind of multiply it out. Does that make sense? So let's check. And do the linear terms cancel out? Yes, they do. Do we get x squared minus 25? Yeah. So we got it right. Does that make sense? Question?
So if they told you to factor like that, so x plus 5 times x minus 5 would be the answer.
Yeah, x plus 5 what? Minus 25?
No, like x plus 5 times x minus 5 would be the answer.
Yes. Why is this the answer, guys? Isn't it? So why would this be the answer? Because this is not really simplified, is it? You got parentheses and so forth. But how come this is the answer in this case? Is that what you're asking? Because don't we want to get rid of the parentheses and so forth? Not in this case. Why not? Because my instruction is to factor, not to simplify, is it? Does that make sense? Because if this was to simplify, you would be done. X squared minus 25 is the simplest way to write this. But if I ask you to factor, I want to write it as a product. You see the difference? All right, good. Here's example 2. Now this looks a little bit different than what we had before, but not that much. So our first step is to do what? Look for, class, always look for GCF. Do we have any GCF for this? 100 and x squared. Do we have any GCF? No. So we don't have any GCF. So only thing that's left for us to do is see if this is what? Difference of square. Is this difference of square? In other words, would it fit this pattern? Something square minus something else square. Does it fit this pattern? Michael, does it? What's my A? My A is 10. You're right. Then I write 10 squared, right? My A is 10. What's my B, Michael? X. X is my B. Well, yeah, so you square B, so it's x squared. That's exactly right. So Michael, I know that this is 10 squared minus x squared. So how does this factor to? Yeah, look at the pattern. We just learned that one. Oh, wait. My A is 10. So you should start with 10 first. 10 plus x times. No, you should start with 10 again. 10 plus x times 10 minus x. Would you not agree? There you go. Any question? Is it okay to switch the x's around? Like, could I rewrite this as x plus 10, x minus 10? No, that would be wrong. Because remember, we don't have commutative property for subtraction, do we? But is it okay to write it this way? 10 plus x times negative 10 plus x? Is that okay? That's fine. But this will be wrong, right? Don't write it this way. This is wrong, right? You understand what I'm saying? Because a lot of times people just want to write x first, you know. If you're going to do it correctly. It's going to be negative x, not just x. Right? Because for subtraction, you know, there is no commutative property of subtraction, is there? Any question on example 2? Are we good? So far we've seen pretty simple examples of this difference of squares, right? So do they have to always give you nice A and B? Like so far the A was like x, B was 10, things like that. Do they always have to give you those? No. They could always give you something interesting. You even see how they get a little bit interesting? Here, take a look at this one. Okay, so example 3, they give you 64x to the 4th minus 25y to the 2nd. Okay? Now, everybody write this down. We should all look for GCF, right, Sarah? Do I have any GCF for this? No. Okay, so that's how, you know, we can't really do that one. So since there's no GCF, do you think it'll fit this pattern, a squared minus b squared? In other words, do you think this is the difference of square? It kind of gives me a good indication, right? First of all, you got this subtraction sign here, and you have 2 terms, right? Now, would it be a good sign if you have 3 terms? Can 3-term polynomial be difference of square? No. For difference of square, you have to have 2 terms, right? And then subtraction in the middle. So who thinks they know what our a is. This time they try to get a little bit creative. Instead of just